Have you ever pondered the possibility of life existing on other planets while gazing up at the night sky? Where do you suppose life would be if it existed in the cosmos on a different planet? For a long time, scientists were perplexed by the idea that there may be life on other planets. However, things have changed, and today's scientists are well equipped with the tools and resources they need to solve the mysteries of our cosmos. Welcome to Cosmos Observer, where nothing goes unobserved in the universe. And join us as we explore the James Webb Telescope's startling new finding on artificial light. The new James Webb Space Telescope, which is 100 times more powerful than the Hubble Space Telescope, is the more powerful telescopes that scientists have ever built. Infrared astronomy is the primary focus of the James Webb Space Telescope, or JWST. Being the most powerful telescope ever placed in orbit, it'll be able to observe objects that the Hubble Space Telescope can't due to their extreme age, great distance, or low brightness. This is expected to open up a wide range of astronomical and cosmological investigations, including perspectives on the formation of the first galaxies and stars, as well as detailed atmospheric characterization of exoplanets that may be habitable. In contrast to Hubble's 2.4 meters, the primary mirror of the JWST is composed of 18 hexagonal, gold-plated beryllium mirror segments that collectively measure 6.5 meters in diameter. In comparison to Hubble, the Webb telescope now has a light collecting area that's around 25 square meters larger. Compared to Hubble, which observes near ultraviolet, visible, and near infrared spectra, JWST will see in a lower frequency range from long wavelength visible light, red, to mid-infrared. The American Space Agency has reached a significant milestone in the creation of the new JWST. The sun shield, which keeps the JWST cool, is its most conspicuous component. For the telescope to operate as intended, this cooling is required. The shield, which is as huge as a typical tennis court, had to be folded to fit within the launch vehicle. The side that faces the sun will be around 260 degrees Fahrenheit warm, while the opposite side will be nearly 370 degrees below zero cold. Researchers at Harvard University have shown that the James Webb Optical Telescope may be configured to look for signs of artificial LED lights on the planet Proxima b, which circles one of the sun's nearest stars, Proxima Centauri. This fascinating new planet can be found in a system that's only 4.2 light-years from our own. While gathering information about our sun's nearest star relative in August 2016, scientists discovered this possibly habitable planet. The JWST will presumably offer greater images in the future as researchers work to pinpoint additional features of the planet. A team of researchers and business executives unveiled the groundbreaking Starshot, the first step toward bringing humanity to the Alpha Centauri system, just before Proxima b was found. The goal of the global initiative, which has garnered $100 million from Russian businessman Yuri Milner, is to greatly speed up the development of a workable space probe capable of traveling between stars. The Proxima b discovery gave engineers a hard but doable technical aim. A probe would have to move at 1/5 the speed of light or faster while avoiding observable debris to get to Proxima b in the time it would take the typical scientist to complete their career. Then, during a flyby of the Proxima system at a speed of 37,000 miles per second, it would need to gather pertinent information and send it 4 light-years back to Earth. Beyond that, proponents of the Starshot project see its likelihood of success as more than simply information about a new world, since it would represent humanity's ascent to new heights. Exoplanets, or planets outside our solar system, will be studied by scientists with the aid of the JWST. Exoplanets were incredibly hard to even find until the JWST was launched. One exoplanet in particular has drawn the attention of researchers, but they have had to wait for the JWST to be able to investigate it in depth. So why are exoplanets so difficult to find? The first factor is that they're so far away. In the absence of a significant advance in space travel, the nearest stars outside of our solar system are so far away that we cannot send people there. The second factor is that these exoplanets circle bright stars, which makes it difficult to observe the planets in their orbit. Scientists had to come up with alternative ways, such as the transit method, which watches how the light from a star briefly dims as a planet passes over it throughout the cycle. It's like attempting to examine from a distance an item put in front of a bright light. The Kepler Space Telescope uses this technique to find exoplanets, and scientists may use the data to estimate the size and orbital periods of the planets. However, with the deployment of the JWST, the task of exoplanet hunters will become simpler, and one of the exoplanets the scientists are keen to explore is Proxima b. An extraterrestrial planet called Proxima b resembles Earth in practically every way. This exoplanet is just 17 times as large as our planet and is only 4.2 light-years away. A group of scientists have uncovered some information using the axial spectrograph for rocky exoplanet and stable spectroscopic observations, or ESPRESSO, that strongly suggests Proxima b has evidence of life. The European Southern Observatory's extremely big telescope in Chile is now housing the Swiss spectrograph ESPRESSO. Spectrographs detect things and separate the light emanating from such items into constituent wavelengths, allowing researchers to examine the object more closely. Proxima is a very recent planet, having been detected in 2016 by ESPRESSO, and its mass was estimated with an accuracy of more than 1/10 of the mass of Earth. The position of Proxima b with the nearest star to Earth, Proxima Centauri, is more intriguing. It is located in the habitable Goldilocks zone, or the route that revolves around its star. This suggests that given the temperature, liquid water may exist. One prerequisite for life as we know it is water. In contrast to the Earth, which takes significantly longer, Proxima b completes its orbit around its star in just 11.2 days. It is a red dwarf because Proxima Centauri is a far less powerful star than the Sun. The exoplanet can still sustain life. In fact, Proxima b receives almost the same amount of energy from its star as the Sun does for the Earth. Due to its tidal lock with Proxima Centauri, Proxima b has a constantly dark and permanently bright side, since one side of the planet always faces the star. The existence of an atmosphere on Proxima b is one of the things that researchers will verify using the JWST. The exoplanet may need an atmosphere to shield it from potential radiation from Proxima Centauri. If Proxima b has any water on it, the atmosphere will also help it retain it. On Proxima b, there may be another indication of life that researchers want to investigate. Here, the JWST will be of great assistance. In actuality, this is one of the clearest indications of extraterrestrial life on an exoplanet. The inspiration comes from Proxima b's tidally locked relationship to its star. As we have said, Harvard astronomer Avi Loeb hypothesized that technologically adept aliens may be employing artificial lights to enlighten their surroundings, since one side of the exoplanet is permanently dark, exactly like you would flip on a light switch when it becomes dark. These artificial lights may be obtained using strong mirrors or extremely bright LED stylites. Simply capturing these brilliant lights will do. This is where the JWST comes in. By doing so, we can confirm that there are aliens on the exoplanet. However, is it conceivable that aliens would decide to reside or remain active in Proxima b's shadowy regions? Chinese scientists recently succeeded in landing on the permanently dark side of the moon, which raises the question of what the aliens on Proxima b are up to in the darkness of their home planet. Loeb proposes that we seek telltale traces of LED light waves in the light from the planet and its host star with the JWST's near-infrared sensor to determine the presence of artificial light on the exoplanet. He's a member of the Starshot project, which aims to deploy ultralight, ground-based nanocraft to Proxima Centauri at breakneck speeds, so they can arrive at the star in a few decades. The astronomer also published a report in which he asserted that the interstellar asteroid Oumuamua was the first instance of alien intelligence being encountered by humans. He's presently concentrating on Proxima b. According to Loeb, his team looked at a variety of possibilities, such as artificial illumination that has the same spectrum as regularly used LEDs on Earth, and a narrower spectrum that produces the same amount of light as all artificial illumination on Earth combined. They understand that the JWST can detect LED-type artificial lights, which account for 5% of stellar power. This notion of artificial light demands a perfect performance from near-infrared spectrograph or near-spec instrument on the JWST to conclude that it could be able to detect artificial light. Loeb's colleagues employ the JWST exposure time calculator to estimate what would be detected during any particular period. This allowed them to calculate the probability of detecting various flux values and detecting those with a wavelength that corresponds to artificial light levels that should be anticipated from a civilization living in perpetual darkness on Proxima b. What are your thoughts about the existence of intelligent alien life forms? Let us know in the comments section.